So as discussed, abstract class is always a base class, and it's a class which cannot be instantiated. That means we cannot create the object of abstract class, right? If we cannot create the object of abstract class, then what is the use of abstract class? Abstract class is used to get inherited. Okay, it is always used by the child class. Okay, and to create an abstract class, there should be at least one abstract method. There should be at least one abstract method. Without that, creation of abstract class is not possible. Right? How to define an abstract method? At the rate abstract method, that is a decorator name. So we have to decorate the function with abstract method to make that as abstract method. Okay. One class can contain at least one abstract method followed by a non-abstract method. All the abstract method must be implemented or overridden by the child class. Okay. So what are the use case of creating abstract class? The use case is when you're creating your application, there might be something which are common, and then there might be something which are uncommon, unique, and then there might be something which are common with different logic, right? There will be some method which are common with same logic. Okay, there will be some methods which are common with different logic, and there will be some method which are unique. Okay, unique method will go to the class, that particular child class. Method which are common with the same logic will become the normal method, but the method which are common with different logic, okay, that will be considered as an abstract class. Okay, that will be considered as an abstract class. Now when we create an abstract class, we need to define ABC, import capital ABC, abstract method, define a class, vehicle is coming from ABC, and here I can define abstract method. So now what I have done, I have created two classes. The first one is the abstract class, which contains abstract method start and non-abstract method company name. Okay, and then I'm creating a child class car which is inheriting vehicle. Okay, there it is overriding start and it has its own method get car color. Okay, now if you look at this, start is mandatory. I have to override because that is an abstract method. If I do not override, I'll not be able to execute the program. Okay, company name is optional. If I want, I can use the parent class logic, and if you feel like no, this logic has to be changed, then you can override, right? But this company name will be used by all the child classes. That it can be used by all the child classes, right? Pass means you are creating just a method without any logic. There is no use of writing the logic, right? Because all the abstract method will be implemented by the child class. Yes. If you, yeah, that is a normal method, but if you decorate abstract method, then even that will become abstract method. So even that has to be implemented by the child class. Why you are creating abstract code? I've not oh, this is this decorator name. Okay. So if I put this decorator over here, then even this company name has to be overridden. I cannot, I have to override the company name also, right? So a non-abstract method are those methods which has common implementation, common features. That can become the non-abstract method. So it can be used by all the classes. Abstract method are those methods which has to be there in all the classes but with different logic. If I create a bike, one more class bike, the way we start the bike and the car both are different, right? So start functionality will be different. But since both has the same company, so the company name logic will be same, right? Clear? Clear, right? Okay. Now inside each functions, what if we get any exceptions? How are you going to handle those exceptions? Right, I've created a function, and that function maybe like I create a function, let's say or I write a logic, not create a function, but I write a logic which is taking the age. If age is less than 18, and print. This is simple logic I've written, right? Okay. What will happen if I enter something else? Let's say in this case, it will give me the exception, right? Right? And my program will terminate. What if I want to handle this exception? I should not throw this kind of message on the to the user. User will never understand what's happening. So either we have to give a friendly message, right? Or whenever I get this kind of error, then I might need to handle in a better manner, or I want to take some other action. I want to do some other action whenever I get the exception. Maybe I want to send out an email to the admin that this user is getting error, right? That means after the exception, you want to take the next action. Now I am not able to take the next action because my program terminates, right? So what we need to do is we there is a concept of exception handling. We have to handle this exception. Now, exceptions, when I say exception, it could be an error, it could be a bug, or it could be nothing, right? For example, if I don't want the age less than 18, then what I'll do, I'll make that as an exception. So exception may or may not be the error. It's just like what the expected behavior when you are executing a program. If your program is not having the expected behavior, in those scenarios, what we need to do? We need to handle those scenarios. So exception handling is for that. In this program, if I want to handle the exception, then what I need to do is put a try block. Exceptions exception can be handled using a try block followed by except. Clear? Just execute the program. Okay. Now if I want to handle the exception, okay, when I execute, again let me pass some wrong input. Now it's handling in a better manner, right? Whenever there is an error, whenever there is an error in your try block, it goes to the except block. Okay. Whenever there is an error in the try block, the program goes to the except block. And inside the except block, you can write the logic how you want to handle the exception. Indentation problem. See, my code is inside the try block. Each and every, we are not avoiding, we are handling it. It's not getting avoided, it's getting handled. Index error, everything, any kind of exception you can handle. Okay. We can also handle multiple exceptions. It need not be the case that all the exception I'm handling the same way, right? If I'm getting value error, then I might do something else. If I'm getting a type error, then I might end up doing something else. So if you want to handle the exceptions differently, then we can have multiple except block. And here you can provide what kind of exception you want to handle, right? And here you can write the logic. Okay. right? Ensure that the basic exception should be defined at the bottom. Okay. Now what happens whenever you get value error, it goes to the first except block. Other than value error, if you get anything else, then it goes to the second. Clear? So now ideally we write our code within the try block. We can also have nested try block. Maybe I want to handle this particular line of code differently. So try. What is the use of nested statement? So any error comes in this line age, it will go to this except block. Okay. Other than this, if any error comes in this two line, then it goes to this except block. Clear? Clear? Now this entire thing should be part of a function. When you're writing the code, okay, your logic should come under try block, and that try block should be inside a function. Okay. If I want to raise the exception, if there is no exception, but I want to raise the exception, okay, even though there is no exception, if we want to raise the exception, let's say for example, If age is less than 18, that's already written. If age is less than 18, then do this. Okay. If age greater than 18, then I want to raise the exception. So raise is a keyword. And what type of exception you want to raise? I want to raise a value error. Okay. Value error means this one. It goes to this except block. And here I'll say like age cannot be more than, enter the age 19. This is a value error. So it is coming to this block, right? I want, I don't want to raise a value error, so I'll do exception. It will go to the last block. Age cannot be more than. So you can navigate or you can define what kind of error you want. We can raise the error explicitly. Okay, execute this. To handle the, whenever you're putting a try block, there should be an except block. Also, if any error comes, that should be handled by the except block. So there should be at least one except block. If you're not handling all the exceptions separately, there should be at least one except block along with the try. If you give only try, it will not work. You'll get errors. Yeah, you can give value error. I can give here that I want If there is a value error, then do something else. We are just handling this particular line. If this line any error comes, then how to handle. So I'm not handling with this exception, this logic. I've written a separate logic there. Clear? Okay. And it's a good practice to implement exception handling when you're writing the code, because we never know what kind of exception might come up. Okay. If you don't have the use case to handle any of the exception, then give the except block and write a normal message. You can also capture the log. You can also implement some logic within the except block. Okay. Now suppose if there is no error, then I want to execute something. Let's say there is no error in the try block, then I want to execute some piece of code. So for that there is one more, there's something called else block. Else block will execute when there is no error in the try block. Okay, else block will execute when there is no error in the try block. Okay. Now if I give some valid number, let's say 15. See, there's no exception in the try block, so it went to the else block also. Okay, it went to the else block also. There's one more block which gets executed irrespective of whether there is an error or not. Okay, which is your finally. So finally block will execute always irrespective of there is an error or not. So for example, let's say I have a database connection. I'm doing a database connection to insert or delete something from the DB. Now there might be an exception while inserting to the database, right? Or there might be no exception. In both the case, we have to close the database connection, right? We cannot keep the connection open. So that the logic of closing the database connection can go to the finally block. So irrespective of whether you are getting error or not, finally block will always execute. Okay. See, finally block will always execute. Now let me give some error also. Then also finally block is executed. Okay. Else and finally block are optional. If you have the need, if you have the requirement, then you can use. Otherwise, it's not mandatory. Except it's mandatory whenever you're defining a try block. Stop it because it's still running. So stop. That box is there. Yeah. Clear? Okay. So when you're creating the functions, right? This should always be inside the function. Let's say show age. Okay. Should be inside the function. And then you can call the function which will right. So this is a good practice. When you write a code, it should always handle the exceptions. Here. So now we are left out with file operations, modules and packages. How to, what is modules and package, what is file operation. I'll also show how to create a custom exception. Okay. After these three topics, we have multi-threading, database connection, and overview on APIs, Django. What is API and how to work. Right? So I'll give some assignment tomorrow, which includes your hoops concept. Okay, and as and when we complete file operation and modules packages, those feature also we need to include in the same assignment. So that will become a project. Okay. Storage is a function. We are calling. We have defined everything inside a function, right? I'm calling it. Okay.